Hey everybody, it's Mr. Zappo here. Today's video is going to be our notes for the second day of Chapter 4, sections 4.1 and starting into section 4.2, where we're going to be writing quadratics in vertex form to start with, and then we're going to start taking a look at standard form. Those are our two learning targets. So, recall, when we have vertex form, the vertex is at h, k. H is the x-coordinate, k is the y-coordinate, and the axis of symmetry is always that vertical line through x equals h, or the vertical line that is x equals h. So as long as we know the vertex and any other point, we are able to calculate or to write this equation in vertex form. This first example, we're given that the vertex is at -5, 4, which tells me that h is -5 and k is +4. The nice thing is I'm also given a new point. The new point is telling me that I have another point on here where x is -2 and y is +1. Why that matters is because in my vertex form, y equals a times x minus h squared plus k. The only thing they have not given me is a. So as long as I have these four things, I can start substituting in, which we are about to do. Specifically, h is -5, so I can plug in my -5 here by making this +5. K is at a +4. I can substitute in my 4. But I now know I have another x-coordinate at -2, so I can get rid of my x in my function and write in -2. And I can get rid of the y in my function and type in 1. If I go through the rest of this and solve for a, I then have my function. So let's go through the process. 1 equals a times 3 squared plus 4. 3 squared is 9. Subtract 4 from both sides, I get -3 equals 9 times a. And it's not squared anymore. Divide both sides by 9. My a is -1/3. The vertex and a is enough to put into my vertex form. Y is going to be equal to a, which we just found to be -1/3, times the quantity of x. My h coordinate is -5, so +5, squared plus 4. That is vertex form given the vertex and one additional point. Had they not given me the additional point, I could not have done that. In the next example, they haven't given me the vertex per se, but I can calculate or figure out, identify what that vertex is. So I'm going to start looking at quadrant 1 here. I have the arch of the Sydney Harbor Bridge is approximately 500 meters long and 85 meters high. What quadratic function models the curve of that arch? Assume the arch starts at 0, 0. So I'm going to assume it starts here, and it's going to arch up and eventually come back down over here somewhere. And this over here somewhere is not an arbitrary place. That's 500 meter long bridge, so this is at 500, 0. I also know the height is up here at 85 meters. That's my y-coordinate, because y is going to judge the height. This is a symmetric figure. That was something that we have talked about. So the vertex is actually going to be the exact midpoint of 0, 0, and 0, 500. So I'm going to have it at 250 in my x direction. Well, I now have my vertex, and I have 2 points. I think this point's the easiest one to use. I can use either one of these points following the same method we just did. So let's say I use this as y and x, and use this as h and k. My y is 0, my x is 0, and then I have h and k. H is 250, so minus 250. K is 85, plus 85. I'm not going to go through and spend the time on the calculation now. You should probably pause, make sure you can do this full calculation, unpause to check your work. in doing this calculation, I would leave this as a decimal. Now the decimal we got was 5 digits long. Put all 5 digits into that equation. And if it's a 35-digit decimal, then you can round at some point. But for now, if it's a small decimal, short decimal, 5 digits or less, put the exact decimal that's in there. But I now have my vertex and I have A. We can go right to my vertex form. Y is going to be equal to A, which is negative 0.00136 times the quantity of x minus my x coordinate, 250 quantity squared, plus the y coordinate of your vertex, which is 85. That's the equation. If that wasn't clear, if that was too fast, go ahead, pause, or rewind to go back and watch. We will have some practice problems here at the end and be able to review and follow up later. So yesterday we saw that the standard form for a quadratic function is f of x equals ax squared plus bx plus c, where a is not equal to 0. A can't be 0 because if it were 0, we wouldn't have an x squared term. It would be linear, no longer quadratic. So let's talk about some key features of standard form. If a, the coefficient of my x squared term, is greater than 0, that means if it's positive, my graph is going to open up. If a is negative, my graph is going to open down. And we'll go ahead and spell that correct. And remember, if it opens up, it has a minimum point. If it opens down, it has a maximum point as the vertex. The y-intercept is always going to be when x is 0. So if x is 0, this term goes away, my x term goes away, my x squared term goes away, and all I have left is my c term, so my y-intercept is at 0c. That's going to be my additional point that I get a lot of times. Then axis of symmetry in the x-coordinate of the vertex. Again, vertex is going to be hk, but how do we get the vertex when it's not in vertex form? It's a calculation based on the coefficients of x squared and x. So we're going to take the opposite of the coefficient of x, the opposite of b, and divide by 2 times the coefficient of x squared. That is the axis of symmetry, so my vertical line of symmetry. And then the x-coordinate is going to be at that point, the opposite of b over 2a. And the y-coordinate is going to be what I get when I plug that into my function. So f of the opposite of b over 2a. And that will become a little bit more clear as we start to go through a couple examples here. So let's flip to the next page and let's take a look at our first example of graphing. We want to graph this the same way. We need to get the vertex, know the axis of symmetry, identify min-max, and all of that information. But we can't necessarily do that right away. We need to recall that the vertex, or the axis of symmetry, these two are sort of combined, and they are going to be when x is equal to the opposite of b over 2 times a. That's where I'm going to get my x-coordinate. So I have to identify a, b, and c first. A is the coefficient of x squared is -1. B is the coefficient of x, it's positive 6. C is my constant term. It's not 0, but it is 3. And now I can do my calculation. My x is going to be the opposite of 6 over 2 times -1. So my x is 3. I now know the vertex is going to be at 3 something, and the axis of symmetry is at x equals 3. If I want, I can go and graph that axis of symmetry with that dashed line just so I can see my line of symmetry. Now, to get my vertex, I need to find f of 3, which means y is going to be equal to, I'm going to plug my x-coordinate into all of my x's. Negative and parentheses 3 squared plus 6 parentheses 3 plus 3. Now I'll show you the display for my calculator. I put that 3 in parentheses. I think that's going to be a good habit to get into as we start inputting negative numbers in for x. As we square it, I put the negative outside. That's this negative here. I think that's, again, a really important habit to get into. This is not going to give you a negative 9 or a positive 9. It will give you a negative 9 plus 18 gets you your 9 plus 3 is your 12. So the order of operations is extremely important, and how you plug the numbers into your calculator will be really important as well. So the moral of that story is we get y is equal to 12, so my vertex is at 312. So I don't actually have 12 on here. I'm going to estimate that that's right about here. Plot that point. That's my 312, which is my vertex. A in this case is -1. That means that this is opening down and has a maximum point at that vertex. The y-intercept is going to be my additional point I need. That's at 0, 3, because it's always at 0, C. So I can plot 0, 3 as my y-intercept. I now know what one branch of this parabola is going to look like. This is a curve, so I'm not going to draw a line. I'm not going to take a straight edge out. I am going to curve this, start at the vertex, and go down. The line of symmetry tells me what my other point will be. I am 3 units away from my line of symmetry, my axis of symmetry. I'm going to go 3 units in the other direction. So my second point that I can graph, it's not a y-intercept, but it's my line of symmetry. My point that I get symmetrically is at 6, 3. And that allows me to graph the second branch of my curve. I am not looking for perfection here right now. I am looking for this to be a curve. It's not an absolute value graph. And now, talking about domain and range, we talked about it already before. The domain, my x values can be any x value. This is going left forever as it goes down forever, right forever as it goes down forever. So my domain is going to be all real numbers, but my range is not. It's going to be my y values such that it's only going down from positive 12. So y is less than or equal to 12. What I'd like you to do now is press pause and try part B. So in this case, we should get 1.5 for your x-coordinate of your vertex and negative 1.5 for your y-coordinate. And if you did not get that, remember, we are substituting into x equals the opposite of b over 2 times a. And in this case, b is already -6, so that would be positive 6 over 2 times 2. That gets us 6 over 4, or 3 over 2, which is 1.5. Plug that in, we get negative 1.5. Go ahead and write down on a separate sheet of paper what questions you have, what parts are confusing you right now, and when we get back together, we'll be able to go through and review all of your questions. But at this point, I'm going to switch over to a second video to do the second part of our notes as we are changing concepts a little bit, and we're going to go from standard form into vertex form. So go ahead and you can end this video and go back into Classroom to open up the second video.